course, there is an enemy outside, but I'm not talking about the enemy. So you can see that in this situation, it looks like everything is perfect. We are not talking about how the key is generated, but it looks okay. But now in the real situation, we may have, for example, 3 people. I have 3 people, A, B, C. If I have 3 people, then A and B will need to communicate. I call it KAB. This is KAC. This is KBC. Right? With the requirement that KAB must be not equal to KAC, be not equal to KBC. Because if the key is the same, that means they can listen to each other. Right? Must be different. So you can see that if 2 users, we can have 1 key. That's 9. 3 users, so this one is 1 key. 3 users, we have 3 keys. So now let's consider if I have 4 users. 4 users, you can start thinking that, well, 4 users is starting to be complicated because you need to have this key, this key, this key, this key, that key, and that key. Yes? And remember, all of these keys must be distinct, must be different. So now we see that if I have 5 people, so that means you need to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so you can see that this is 10 keys. Here we will have 6 keys. Right? So now the question will be, if I have n users, because you have in the internet, you have n users, how many keys will you have? So you can see that if I want to derive like this, you need to see, for example, this one. Let's see one. We have 4 users. 4 users, that means 1 user will have 3 keys. 1, 2, 3, yes? So if I have n users, that means every user will have n minus 1 key, yes? Okay? And then you will have 1, 2, 3, 4 for these 4 users. Here I have n users. That means the total is n times n minus 1. Can you follow? Okay? But the thing is, in order to allow for communication, the key for this one must be the same as the key for this one. So what I mean is, the key AC is equal to the key CA. If they are not equal, they cannot communicate. Right? So that means you need to divide it by 2. So you can check. There are 2. 2 times 1 divided by 2, 1. There are 3 people. 3 times 2 divided by 2, 3 keys. 4 people. 4 times 3 divided by 2, 6. 5, and say 5 times 4 divided by 2, 10. Yes? So that means you will need this many distinct keys. So even though we see this many distinct keys, look like it's still okay. But if you think about in practice, this one doesn't make sense. Because what happens is, let's just consider 4 users. 4 users. So A has to have a key with AB, AC, and AD. But we require these 3 keys will be different from key that is called CD. You understand what I mean? So you see, there is a key that's called AB, AC, AD. These 3 keys must be different from the key that is called CD. But this 3 key AB, AC, AD has nothing to do with CD. But they have to be different. So that means like this. Suppose that I have a Facebook account, for example. I have 1,000 friends, for example. Then among these 1,000 friends, so that means I have 1,000 keys. Okay? But what happens is, these keys must be different from the key of somebody that I don't know. Must be different from that. Because if the key is the same, what I send to someone will be able to be listened by this guy. You see what I mean? So in reality, this one, it doesn't make sense. So that's why symmetry key has a problem with key scalability of the key. Scalability of the key. Okay? So that's why we cannot use this for so many users. If it is talking about A and B only, no problem. But when you start talking about n users, then there is an issue. Okay? Yeah, everyone clear with the issue? So that's why we need to study the so-called public key cryptography. The idea of public key cryptography is completely different. The idea of cryptography, public key cryptography, is later on we will see formally. But the idea is like this. You have a person A, a person B, person C, or so many people, right? So many people C, no problem. So what happens is, everybody will need to be equipped with two different keys. So for example, A will have a key, so I just draw a key, this is a key, like that. This is called SKA. That's the private key of A. This one is another key. How comes the key so like that. C as another key. This is the key of the key. You know, when you play the game, there is one key that will open the key. This one. When you play Clash of Clans, you will see this one. Alright, so what happens is, for every single key, there is a matching key. So what happens is, for example, for B, so I just wrote it here. For example, there is a public directory here. We say like this. For A, there is a padlock that's written belong to A. For B, there is a padlock belong to B. C, there is a padlock here belong to C. Right? So that's the setting. And now, for example, A wants to send a message to B. What does A do? A will write in a piece of paper, like that. Then what A will do is, A will get a box, put it in a box, and then A wants to send to B, right? Then A will get this padlock from B and lock it. Like that. And then send this by the internet. So you can see that because this is locked with this padlock, only B can open this one. Even A herself cannot open this. Because this message is created by A, but A cannot open this one. The one that can open this is only B, because B has the copy, has the key to open this padlock. Makes sense? Right? This is how public key cryptography works. And so public key cryptography works just as simple as this. There is a pair of keys. One is the key, one is the padlock. So when you want to encrypt, you use a padlock. That's the so-called encryption key. When you want to decrypt, you use a decryption key. Okay, the encryption key is this key. In order to make the public key cryptography secure, there is a requirement. The requirement is this. If you hold this key, take a key, you can go to locksmith and you can generate as many padlock as you want. So basically, I have a key, I go to locksmith, and you make a padlock for me? No problem. Okay, how much? $10. Right? But now, if you bring a padlock from someone, you go to locksmith. Locksmith, can you create this one? I have $100. Locksmith said that I cannot do this. Why? Because at the bottom here is written as a message for locksmith saying that do not create the key. That's why the locksmith will follow this rule. Do not create the key. See? Then in this case, this is to guarantee security of public key cryptography. Because if there is no such requirement, then the system is not secure. So what we do is, I just take this padlock, C takes this padlock, and create a key. So that means now C can open this one, right? And unfortunately, it's not true. So nobody can open this except you. Yes, do you understand? So this is the simplest explanation of public key cryptography. So how we can really achieve this with two sets of keys. Okay, these two sets of keys.
Is it A and B before which B?
If you want to know in practice, so in practice, how can we actually achieve? If I know the secret key like this, I can find the padlock. But if I give you padlock, you cannot find the key. Actually, we are using this in practice already. For example, if you have actually you can find the key, but it's very hard for you to find the key. So to give you an example is that you have a phone book. I don't know in Singapore whether you still use a phone book. You have a phone book, it's a phone book. That's the first phone book. Maybe no more. So, but in the past we had like that, right? In that big phone book, basically what happens is, if I give someone's name, you go to the name and you can find the phone number, right? But if I give you the phone number, I give you the book, you can actually find that person's name. But actually very hard. You need to check this one by one. Maybe it takes years to do that. Right? So that's basically how it works here, precisely. So actually, maybe it's possible to find the secret key, but it's very hard. It takes a lot of time. Okay? So that's why we cannot